backwards. One is synthesis, one is analysis. Sometimes problems are hard, so you can go up to a point and then you stop. You cannot go anymore. And you go backward until you meet yourself right there, and then you have the solution. Can you see that? How many people saw that in the reader? Because usually you get something, you don't read it. And this kind of thing is in the first page of the reader. It's a very powerful technique to think, because all problems are solved one of these three ways. All the way like this, all the way like that, or you meet in the middle. Have you ever thought of that? How many people have thought about this way? Let me see your hands. It's very powerful to know that this is the way you solve problems, one of these three ways. Okay? So in this case, I want the number of moles, the ratio of molecules. So if I want to find it, I can just find the number of, the ratio of what? How many moles of C per 400 moles of mixture. Why? Because the ratio of moles is always the ratio of particles, molecules. If I want to find this, I just need to find that, right? So if I want to find this ratio of moles of a gas divided by the moles of mixture, what does it tell me? That's a mole fraction, isn't it? Yes?
Yeah.
Isn't it? That smells like mole fraction. So I need to find the mole fraction of what? C. If I find for a mole fraction of C, then I can find that. Right? Yeah, you follow me? How many people are following me? Raise your hands. Okay. So then I am thinking, how am I going to find mole fraction of C? Okay, let's see. Well, mole fraction of C, I have partial pressures. So mole fraction of C will relate to its partial pressure and P total, P mixture. Right? So I want to find, therefore, now this one. Do I know the other ones? And then I'm finished. I know P total. How about PC? I don't know PC. But I can find it. Why? Because I have three gases and I know the partial pressure of P. And I know the total. The sum of the partial pressure is always P total, isn't it? So now we can start solving. You see, when you learn to solve problems, you don't have to solve many problems. You just solve a few, and that's it. Students make the mistake, they think by solving a lot of problems, they do well. That's not the education, the healthy education. That's sick, diseased education. Healthy education is to learn to think. And if we don't do that, then education is not healthy, it's diseased. Okay? So we need to make it, give it to some medicine to make it well, because it's not so well. It's kind of a little bit diseased. Maybe too much, maybe. All right? So let's try to solve, to think how you learn how to solve problems by thinking reasonably. Then you don't have to labor so much you do and be in such a stress. Okay, so from this then, what do we have? We said ratio of molecules, ratio of moles, mole fraction. Instead of mole fraction, we need to find out the PC. That's it. When PC, we're done, right? So, how do I find PC? I find PC from the fact that P total is equal to the sum of the partial pressures of all, right? A plus B plus C. The partial pressure of oxygen and nitrogen and all gases here makes the total pressure in the room, right? So from this one, we know what? We know this, we know A, we know B, and so we find C, PC. Okay, so if you do that, then from here, we have PC is equal to 4.0 minus 1 minus 2. That will give us 1 atmosphere. Okay, so you have 1 atmosphere PC. And from this one then, XC is going to be equal to partial pressure of C divided by P total. So if you put the values, you will have 1 atmosphere divided by 4 atmospheres. Atmosphere goes away. Mole fractions are always dimensional numbers. We don't have any units, right? And that will come to be 1/4. 1/4. Because you see that the ratio, the mole fraction of C, which is 1/4, is actually the ratio of what? What's the definition of mole fraction? It's a ratio of, you have 1 mole of the gas C, because we're talking about mole fraction of C, so it's going to be a ratio of moles. 1 mole of C divided by 4 moles of what? Mixture. Right? 4 moles of gas is mixture, isn't that right? And that's the ratio of moles. Well, I want the ratio of molecules to be per 400 molecules. So, if I want to go to 400, I multiply both of them by 100, because the ratio will not change that way, right? So if I multiply this one by 100, then I don't have to disturb my ratio, which I shouldn't disturb my ratio. Okay, so I multiply by 100 both numbers, and that will be equal to 400 moles C divided by, you multiply both of them by 100, so that's going to be 100 divided by 400. Why did I multiply by 100? Because I want to make appear on the denominator the number I'm looking for, per 400, right? That's why I multiply by 100, to make this 400. That's what I want. That's moles of A, B, C, all of it together, mixture, right? So I have the ratio to have on the numerator 400. Now the ratio of moles is also a ratio of particles, molecules. And therefore this number then is going to be, from here, that number should be equal to 100, right? Can you see that?